Welcome to this bi-weekly in Linux gaming. In today's video, we're going to be looking at things that are happening in the Linux gaming ecosystem. And in today's video, there is two good things that just happened before I've started this video. So this video is going to be pretty damn awesome, full of a decent amount of content. So yes, you can expect this video probably to be around 50 or so minutes. Hopefully it's shorter if I don't talk too much like I am right now. So the first one we're going to talk about is FSR 4.1 has released 4 RDNA 3 GPUs. This is awesome, I would say, and it's really good that AMD is doing this. And they also said, because they originally announced this a couple of months ago, they said they'd bring it to RDNA 3 GPUs, and then they'd bring it to RDNA 2 GPUs later down the line. So I have an RDNA 2 GPU still. It's running great. I don't really have major problems with it. I can play most of my games perfectly fine. But it's really good that FSR 4.1 has arrived for RDNA 3, and then hopefully maybe a couple of months later, they'll bring FSR 4.1 to RDNA 2 users. But we can see here on the difference, if we full screen, we can see on the right here, FSR 4.1, it looks a lot more sharper, just clear as day. I don't know how accurate this is because this video is made by AMD, so you know the way they show the testing might not be as good as a different YouTuber that might test this and do more videos and stuff of different types of games and comparisons. But we can see that it is a lot sharper with 4.1 versus 3.1, which looks a lot more blurrier. You can just see in the hair here, the strands of hair look pretty blurry. Versus over here, looks pretty sharp. Or the carton here, it looks pretty sharp with like this wet stain over the blanket thing. It looks more sharper on 4.1 versus 3.1. Basically all of it, like the wheels and everything just look more sharper. If it looks through the video, and if we freeze here, we can see again, shield looks a lot more sharper. Yeah, the rocks look a bit more sharper as well. It's more blurry, but of course you're looking at through a video of a video, so it's going to be downscaled a lot versus when you actually try it when you play a game. But what about when it comes to Linux support with FSR 4.1 on RDNA 3? Well, when it comes to that, you've got Proton, so Valve is most likely going to implement this, if not already. It really depends on how AMD implements their FSR technology, if it needs new code to be improved on top of what is already there in Proton to get 4.1 working for RDNA 3 users, or when it comes to if you want to do a game that doesn't have FSR 4.1, you can use custom Proton runners like Karcher Proton, for example, and then use the environment variable to upgrade the FSR upscaler that's in the game. So you can see here on the Proton Karcher OS GitHub, there is the Proton _ FSR4 _ upgrade, which will automatically download the AMD XCFFX64.dll and upgrade games with FSR 3.1 to FSR 4. So I'm guessing this is going to be upgraded soon with the environment variable so that there is a newer version that gets pulled as well, wherever it does get pulled, which is probably from AMD's like official website servers repo somewhere. They'll grab it. So this should get upgraded soon, if not automatically. So if you have an RDNA 3 card and you want to use FSR 4, that then should work properly on games that don't have FSR 4.1 yet. They're still using 3.1, for example. And there is also this environment down here for RDNA 3 GPUs. So it is going to probably get removed, if I had to guess, this environment variable, and then it will probably just be implemented with this environment variable, and then you can just upgrade those games that don't have it. And as always, when it comes to using these environment variables, do not use them in multiplayer games. I know how multiplayer games don't really update their upscalers. They take a lot longer to do it than like solo story-driven games like to They're just a lot more faster at upgrading those things. But please don't use these environment variables because you can get banned in those multiplayer games. And the next big thing that has released recently is the Steam machine. The prices and the announcement of when you'll be able to actually buy them has happened. And as you can see here, this is the price for a Steam machine that has 512 gigabytes of storage. It's $1,609. That is a tough pill to swallow. I am not gonna lie. When it comes to my opinion, it is not worth $1,609. But I know that the industry and economy right now is completely ruined right now because of AI buying so much memory, and that of course affects everything that goes into the Steam machine, basically the RAM, the storage, and I don't think it comes with a micro SD card, but it has a micro SD card slot. But even buying a micro SD card is a decent amount more expensive than it was, a couple years ago. So I do think in the future, this will probably go down in price if the memory and everything starts to become a lot more accessible and it's not as expensive to actually get the memory. Because I don't think Valve ever wanted the Steam machine to be at this price, and the Steam machine was meant to launch a couple months ago, but that didn't happen, and they had to change the date, and then they had to say to AMD on their earnings call that they were on track to releasing mid of the year, and as we can see, yes, but the prices, it's rough. Definitely rough. And again, I'm guessing in the USA, it's probably $1,100 or something. With DuckDuckGo, it thinks it's roughly $1,126.62. So I was pretty damn close. And of course, you can choose the controller, which will be 1,728 Australian dollars here, which is 1,200 and something. Then you got the 2 terabyte, which, it's an extra 500 and something dollars for the 2 terabyte, and then a 2 terabyte with the controller. So I definitely do think that once it does launch, we'll see how many people actually buy it. I bet it is going to go out of stock, not because of lots of people buying it maybe, but probably because they just don't have enough in stock in general. Of course, there's always going to be people who just really adore Valve and the company, and they are a great company. They've done so many awesome things, but this thing is heavily priced for today's market, which is, in my opinion, this machine should not be $1,609. It should be $1,000 Australian, and then it should be 800 or something USD, roughly, is what I would put it at. If everything was perfect in the world right now, like it was 5 years ago, for example, when it comes to memory prices and all that. But as I said in my video as well about the Steam machine, I do think a decade from now, it's going to have been probably a top seller when it comes to just people wanting a small desktop form factor computer that has, 500 gigs of storage, and it can play most of your games in your Steam library. And with FSR 4.1 being released, Valve is going to get that hooked up, and so your Steam machine is going to have a pretty good length of time for its use before you have to buy another computer, which hopefully by then, maybe the Steam Machine 2 will release. I mean, Valve does count to 2, so that should occur. And the next thing we're going to talk about is some improvements that have been made to a specific Zeus laptop, where Google's Gemini AI model was used to solve a problem for a long, lengthy Linux boot time. So if we do read through this here, Google's anti-gravity with the Gemini 3.5 Flash model helped a Linux user sort out a situation where his laptop was taking around 36 seconds to boot to the kernel. which shouldn't be the case for the high-end laptop with AMD Ryzen 9 processor and 32 gigs of RAM. It ended up being yet another case of device firmware issues, but now a Linux kernel patch is pending for working around the issue on the Asus ROG Strix G16 G614 laptop, while discussions are ongoing in getting the vendor to provide a proper firmware fix. So one of the things I do want to mention here, like, it's great that like AI is helping out resolve like problems with people that have major issues with the Linux kernel taking a long time to boot when this laptop is very high end. That's good. But it does show once again that down here in the mailing list code review on the patch, it looks like the AI turned out to be slightly wrong on the underlying cause. Rather than being touchpad related, which is what was set up here, from an ACPI dump, it appears related to the graphics triggering the GPIO issue. In any event, the discussion is ongoing on getting Asus/AMD to work on a proper firmware fix, while this kernel patch will still likely be upstream for those without a updated BIOS. So you can see here where AI has once again just lied to the user because it predicted the problem wrong. If you don't know that, the whole basis around AI is basically that AI is just doing a bunch of math trying to predict what is the correct answer here for what I'm looking at, which it's always been like, if you give code to an AI model, it should be able to figure out necessarily what is the underlying cause. And it got pretty close to what the problem was. But as they stated here, after they got an ACPI dump, more logs to see what the computer is doing, they can actually figure out what the problem is. So in my opinion, it's good that, like, AI is being used to find out an issue with a laptop, but it's also like Linux is open source. The user can figure out by just looking at logs, and there is documentation for how to do this. Now I know, many people don't like reading the documentation and they like to use AI instead, which I guess is okay. I'm very conflicted on the situation because it's like, it's good that they, got somewhere close to what the problem was and then actually figured out the problem, and now they're actually trying to get Asus and AMD to actually fix the problem with the firmware side of things, like maybe LVFS, maybe, or just through some type of BIOS release that Asus will do. That's really good, but again, you can 100% figure out a problem that is occurring on your laptop without even needing to use AI. Like here, where they got an ACPI dump and it actually shows the actual problem at hand, which is a graphics GPIO problem. So some IO GPU related problem, so they can fix it. So anyways, it's really good that they are figuring out and it is being fixed. And we are seeing more improvements from the Valve developers when it comes to improving the older AMD GCN GPUs. This has been happening for many months now throughout 2026. Timur Christoph, say that correctly, he is like one of the main developers that have been improving these GPUs, going all the way back to like 2011, I think it was. And now we're getting to more, like you'd say, modern GPUs, still rather old GPUs, but GPUs that I have personally like seen in my like childhood when growing up type GPUs, because the other ones, I haven't really seen those GPUs before. But as we can see here on the post that Michael has typed out, earlier AMD Radeon Graphics Core Next GCN GPUs are seeing work to improve the GPU recovery process in the event of hangs. This work is yet another improvement for the older AMD GPUs being led by Valve's open source Linux graphics driver team. Timur Christoph of Valve's Linux open source GPU driver team has been responsible for many of the improvements recently to early GCN GPUs, especially with getting GCN 1.0 and GCN 1.1 GPUs over to the AMD GPU driver by default rather than the prior Radeon driver default. The latest work he's leading is on enabling soft reset support for the GFX IP block. So basically, when the GPU has a problem, it's going to to soft like reset the GPU, which is a common thing that is used on AMD GPUs that I know of, both on Windows and Linux, where it can do a soft reset, which can either be done quickly and other times won't be done quickly, and it will be kind of messy when it comes to it resetting itself, which for me personally, I've actually never met an actual big reset of the GPU when playing games. But for these older GPUs, I bet it's really important that that gets put in place. This initial GFX IP block soft reset support is targeting AMD GFX 8 graphics API with the likes of the Polaris, Fiji, Tonga, and Carrizo hardware. But Tim had mentioned to Phoronix he is also looking at implementing this functionality for older GCN hardware too, so potentially going back to GCN 1.0 could enjoy this better reset experience. I think it's really good that Valve is allowing these graphics engineers to improve these GPUs, because unlike Nvidia, where they have completely dropped their GPUs below Turing, on here, Valve is, thanks to it being open source, Valve is contracting these graphics engineers to improve these older GPUs so that people with older hardware can still have a decent experience on the Linux desktop when using these GPUs. And the next thing is Mesa 26.2 merges Vulkan present timing support for X11/X Wayland. So if you don't know what this basically is, it helps with game stuttering to try and avoid that. And it says here by better scheduling when a rendered frame appears on the display, as well as via this extension to receive feedback on prior presentation times to help with frame pacing. So frame pacing, better scheduling with when the rendered frame appears on the monitor, so that it improves the game stuttering experience, trying to avoid that. And this has been brought over to X11, which this is already available on Wayland. So if you're using something like the Wayland driver, this should work automatically because it was merged many months ago. But this does help Wayland as well, because games are still running under X Wayland by default in Wine. So until the Wayland driver gets enabled by default, you have to use X Wayland by default if you don't want to use the Wayland driver. Like, for example, you want to use the Steam overlay. You can't use that on Wayland, so you have to use X Wayland still. So this is going to improve that a lot so that you get a better experience when playing your games on the Linux desktop. Which it does say here that Mesa 26.2 is releasing roughly around August. So if you want to know when you're going to get this, you can either wait for it on Mesa 26.2 release in August, or you can also use Mesa Git as another option. Then we do have some more sensor monitoring support in the Linux kernel. We've got Arctic Fan Controller, more Asus and ASRock boards have sensor monitoring with Linux 7.2. So for those that enjoy keeping an eye on all their system vitals, from temperatures to voltage to hardware monitoring, HWMON updates have seen many device additions for Linux 7.2. First up, the Arctic Fan Controller driver has been merged for managing fans with this yet to be released Arctic cooling product, which if we open the tab here and have a look at it, which we can't seem to find an actual product of this cooler because it hasn't been released yet. There's no photos of it for some reason. But if we continue here, it wasn't done by a third party or the open source community, but Arctic Cooling developed the driver themselves and is already upstream prior to formally releasing the USB-based fan controller, which is what we like to see. We usually never see any big fan cooling companies when it comes to like their own like USB fan controllers or any of the type of cooling products with their own firmware putting it on the Linux kernel. That's really awesome to see, because we have not really seen that, like Corsair or many other brands that make fans and cooling products. They haven't put anything of their code upstream. And usually it requires some reverse engineering to do like things like RGB or controller fans and stuff like that. So it's really good to see that Arctic is, actually hiring a team to upstream their drivers into the kernel. But the Zeus EC sensor driver has been added for the Rogue Maximus ZC90 Extreme, the Rogue Strix B850E gaming Wi-Fi, the Rogue Strix 8650E-E gaming Wi-Fi motherboards. So if you've been wanting to look at sensors on those motherboards, then you'll get sensor monitoring now, which is really awesome. And in the bottom here, of course, we do have the NCT6683IC driver. Sensor monitoring now works on the ASRock Z890 Pro-A motherboard with Linux 7.2. So if you own this motherboard, the sensor will work properly. We're looking at all the different types of things. And then the Dell SMM driver, meanwhile, interesting, added the Dell Latitude 7530 to that driver's fan control whitelist. So that's also good to see. And then there is also new HW MON drivers for a number of new devices, including the analog devices LTC 4283 swap controller, analog devices MAX 20830, analog devices MAX 20860A, Delta E50SN12051, Luxshare LX1308, microchip MEMC1812/13/14/15/33, monolithic MP2985, and Murata D1U74T PSU. Lots of new devices. So really good when it comes to the sensor monitoring side, just as always, just improving. And another big one that has occurred is in the NVK driver in Mesa. There is now DLSS support finally with the NVK driver, which is insane. NVK driver, if you don't know, it is the open source Vulkan driver for NVIDIA GPUs in Mesa, similar to the RADV Vulkan driver in Mesa for AMD GPUs, or the ANV, the Vulkan Intel driver in Mesa for Intel GPUs. So this has been, of course, I've been covering the NVK videos, testing my RTX 2060 and seeing how well it improves versus the proprietary drivers, and it has been improving every year. It just becomes easier and more easier to launch games, and then the performance has been slowly improving. But seeing this is amazing, because this was announced a couple of months ago that someone was figuring out how to get it working, which was a Valve developer. If we do read through this, it says a pull request opened last year by Autumn Ashton was for implementing VK-NVX binary import support as the Vulkan extension needed for NVIDIA DLSS support with NVIDIA GPUs. Thomas Anderson 2 months ago opened a new pull request to fix merge conflicts and other fixes to that earlier pull request, with Autumn having not been as active in Mesa development in recent months. So basically they took the patches and then tried to fix all of the conflicts and then merge it, which is really awesome. So the VK-NVX binary import is the binary extension that applies applications to import NVIDIA CU bin binaries and execute them. The CU bin ELF files are pre-baked CUDA binaries for execution on the NVIDIA GPUs. With VK-NVX binary import, then it's possible to load the DLSS binaries for use with the NVIDIA GPUs via the NVK driver. Awesome. That new pull request is what crossed the finish line today in being in Mesa 26.2 for letting NVK work with DLSS enabled games. Though, as there are some known bugs, for now, the support is hidden by the NVK_experimental equals DLSS environment variable. So with DLSS relying on CUDA binaries, the support in turn also depends upon having compatible bytecode available for the GPU in use by the NVK driver, otherwise things won't work. The proprietary Vulkan driver supports a PTX to bytecode path, but that isn't yet such a thing for the Mesa NVK driver without being able to translate NVIDIA PTX to Mesa NIR representation. So there is a little bit more work to be done, as there's no bugs, so you have to use this environment variable. So we'll see in the coming months, as always, and in the coming years, how good the NVK driver will be, because there is a full team at ALABRI that is contracted to work on this driver. So it's kind of like RAD-V. RAD-V started like 6 years ago by some developers, and then Valve poached them, and they've been, building that AMD driver to where it is an amazing driver now for playing games on Linux. And we'll see with NVK, it's going to be a similar case. And same with AMD as well. Many years later, the NVK driver is probably going to be a really good option for most people, unless you need something like, certain CUDA libraries or whatever, then you'll need the proprietary driver. Then, of course, we have the ANSI rules that have been released, 1.1.42. This introduces plenty of games. Luca has done an amazing job when it comes to adding more and more games to this rules list for ANSI, which, if you don't know what ANSI is, it prioritizes your processes on your Linux computer when you launch certain different applications or games, and it gives it a niceness value, which, if it's higher value, it means that it's a lower priority, and making the process nicer to other processes. So yeah, it's really nice, really awesome on Gasiyu. It's pre-installed, it's already enabled by default, so when you play games, if any of these rules appear in the list, it's going to change the priority of that game so that it's a higher priority over other processes. Then we finally do have Steamos 3.8 that has finally released to everyone in the stable branch, which, as we can see here, and as I have stated over the other beta releases, this includes the new Arch system. So it's been updated with newer packages, a newer kernel, newer Mesa. There's been a bunch of individual changes improving things like screencasting in the game mode. So if you're going to use OBS or Discord in the GameScope gaming mode, it's now been improved, so you have a better screen sharing experience. And of course, there is many other things like the HDMI improvements. So now you can get HDMI VRR with devices with native HDMI support, fixed an issue where allow tearing wouldn't have the intended effect in certain configurations, improved VR frame pacing. When it comes to TV stuff, which is also with like HDMI, that's been improved because this is the release basically for the Steam machine and the Steam frame, or mostly the Steam machine, because they've switched to the Wayland session and they've updated to a newer Plasma, KD Plasma version, which is 6.4.3 from 6.2.5. So they're going to use Wayland by default. It's going to have better multi-monitor support because Wayland does offer that, at least on KD Plasma, it does offer that better experience. And it also includes things like HDR support, which is almost complete, but when it comes to something like the Steam machine, it's going to be a really good experience for this newer SteamOS version. People should be able to just plug in their monitors and launch their applications and just start using it like it's a normal desktop OS. And there was a Steam client beta release that has happened, and some other ones that have happened further past this date, but they've been rather small. But this one was improving the pipewire session logic on Linux. So this is to do with the streaming or recording stuff with the Steam client. So if you do use those features on Linux, which the recording is a little bit broken on the Steam client. Last time I tried it, some of the codecs weren't working properly for some reason. And then streaming, as I've already talked about in the last video of bi-weekly in Linux gaming, the remote desktop experience is not so great. I still have some problems left with it, certain just graphical capturing problems in certain games where the Steam overlay won't appear properly over the game. If you're using like Wayland, that completely like breaks the Steam overlay stuff as well with the Steam big picture stuff. And then also on top of that, the sidebar menu is completely balked. For me at least, it just appears completely broken. So hopefully Steam Valve does continue to improve that experience. But what this does resolve is if you try to launch Steam client with the dash pipewire thing on the end, which you need that now if you want to actually do that. So I'm guessing that's going to be enabled by default. When you launch it, it doesn't appear with the portal system every single time. Usually when you relaunch the Steam client, it would appear with the portal and you have to keep reselecting it. It doesn't do that anymore, which is really awesome. And then on top of the SteamOS release and the Steam Machine release and the FSR thing, 4.1 RDNA 3 official release, there has also been the HDMI 2.1 FRL support, which has merged in Linux 7.2. Now, this isn't going to give you everything that HDMI 2.1 has. That is going to be in the future in a newer Linux kernel release, but with this release, it does add some important, really important features. Which it does actually say here, the feature is initially disabled by default, and the complete HDMI 2.1 implementation for AMD GPU isn't ready for Linux 7.2, but at least the initial FRL capabilities are wired up for allowing higher resolution and higher refresh rates when using modern HDMI displays. So I'm 100% certain that these patches are used in some of the experimental patches as well that haven't been merged in the kernel are backported on SteamOS, as SteamOS does talk in their changelog about introducing all of those really awesome HDMI 2.1 features on Linux/SteamOS. So I do think next couple of months from now, it's going to be fully merged, and then people can just use it on the normal kernel. Then we also do have Wayland does land fractional scaling support, which is awesome to see. So following last week's Wine 11.11 release, they brought alpha modifier support for opacity handling, which is here, the alpha modifier support for opacity handling. So this is also something that has arrived in the Wayland driver. So as we see here, Wine's native Wayland driver now supports fractional scaling. Now for those using this is a nicer UI scaling experience than going through Wayland with today's high resolution displays. The fractional scaling support for Wayland driver was implemented by Etash, the GOAT, and is now merged ahead of next week's Wine 11.12 bi-weekly development release. I can't say his last name, Mathamseti? I really butchered it, explained in the merge request and its superior handling to using Wayland. The idea behind this is to use fractional scaling to make it appear as if the Wine environment is running at the user-specified DPI in Wine CFG, while keeping the windows looking crisp. This enables users to have different fractional scalings per display under Wine without causing blur. This matches the behavior under Wayland and is actually better than the Wayland behavior when using multiple displays with different fractional scaling. The code is merged and ready to go. Hopefully by Wine 12.0 in early 2027 will be a great Wayland native experience with how this driver has been maturing as of late, which I agree. There is a ton of work going right now into the Wayland driver, especially with Etash improving it. It has been quite insane with his own Proton-EM custom Proton runner, which has all of these like rather upstream Wayland patches to test if you want to see how well it's improving. It's a great runner to use. Etash is doing an amazing job improving it. So hopefully with everybody else contributing to the driver as well, that it gets enabled by default, and then we won't have to use the Wayland driver anymore, which will kind of like what Michael is saying, probably 2027 if I had to guess. And then probably Valve will switch to that version of Wine 12 with their Proton runner, Proton 12, and then we'll just have Wayland like working out of the box by default. And then that means also HDR should be ready by then when it comes to the gaming HDR experience, and it'll be all good. Now, another interesting thing that has appeared is with Epic Games. Epic Games has posted a job listing for a senior game security engineer job offer. Now, if we read through this, what this job offer actually does, well, if we just read through here, if we can find it, it says, in this role, you will champion Linux anti-cheat capabilities for Epic, and many other things, reverse engineering cheats and other malicious software. They're looking for someone who is familiar with development and security practices on Linux and Windows, can do debugging, reverse engineering, like I just said, expert knowledge of C, C++, but if we go back to here, championing Linux anti-cheat capabilities. So it seems like they're looking for more developers, because I'm guessing they probably already have maybe 1 or 2 or so people that do maintain the easy anti-cheat for Linux under Proton, because that is supported on Proton through user space. So I'm wondering what they're going to do here. If they're going to try and get their remaining games over to Linux, like Fortnite. I mean, Fortnite is literally being shown on this job offer. Kind of sus if you ask me. The other 2 games, what's that game called? I completely forgot. Fall Guys? I think that's what it's called. That game is already supported on Linux. It used to have some issues back in the day, but that's been completely resolved. It works out of the box now. And same with Rocket League. That has been working even with the new anti-cheat they switched to, or like upgraded to. Still supports Linux. But yeah, there is Fortnite being shown here. So pretty interesting to see if Fortnite is finally going to arrive on Linux through like the Epic Games launcher or something, and it will use Proton in like maybe some specific environment that only Epic controls, maybe something like that. We'll just have to wait and see. And this also comes, you know, after EA also looking for some engineers to improve their EA anti-cheat for supporting Linux properly. So we'll see in the coming months, probably because of the Steam machine, that these final games are going to be supported. And I guess we'll bring up the next thing, which is what I was going to talk about, and I did post about, is that the games on EA, which are all the Battlefield games, for some reason, Valve is showing that they are using and forcing a default Proton runner on them for testing, which is really weird, because if you don't know, all of the modern Battlefield games, Battlefield 1, Battlefield 2042, Battlefield 5, and probably Battlefield 6 as well, are all being forced to use Proton Experimental selected by Valve testing. And when Valve does this, it means that they are, one, probably testing the game with the Proton runner, but also it also means usually that usually when like there's a game issue, they'll force a Proton runner so that everyone can play the game properly without needing to force compatibility or anything. Like, for example, when a game breaks, they'll use Proton hotfix to get patches out really quickly, because they can't release those patches quickly enough with experimental until next week. So it's really interesting to see they're forcing Proton Experimental on these games. It's very, very interesting. And if we look at Battlefield 4, also being forced with Proton Experimental, even though it is supported on Linux, kind of, like you can play on like server browsers and stuff, but if you want to use like public matches, you need to install the anti-cheat properly, which you can relatively easy do. And if we look through Battlefield 3 here, it's also using Proton Experimental by Valve testing. So it's really odd to see what Valve is doing here, if they just forgot that they're forcing Proton Experimental on games that no longer work on Linux, because I don't remember that being there at all. Usually I'm always checking the little exclamation mark info game details to see what's being used here, if Valve is forcing anything, or if I'm forcing a Proton runner, which I usually check force compatibility. So it's really interesting. I really wonder what is Valve doing here? Are they working with EA? Because mostly that's what they do. They'll usually partner with game studios or game companies to get their games working on Proton. So we'll probably see, I bet, probably in the next couple of months, where these games, I bet you, these games will work again. Because Battlefield 5 and Battlefield 1, those games did indeed work on Linux for many years. And I played it on Linux for like 2 years before it got blocked. So I bet these games will return, and we'll finally be able to play Battlefield again, like the newer Battlefields. But of course, you can always play Battlefield 4 or Battlefield 3 if you live in a country where there's enough people playing on Battlefield 3 and Battlefield 4. Now, we also do have KDE improving the gaming latency experience under their Wayland compositor Quinn. So KDE Quinn patches aiming to optimize gaming latency to better compete with Windows. So open source developer Jacob has been working on comparing the gaming latency between Linux and Windows, and in turn working to drive some improvements into KDE's Quinn Wayland compositor so the latency is more competitive with the gaming experience under Microsoft Windows 11. Jacob has been investigating the gaming latency between Windows 11 and Linux with KDE Plasma 6 using a teensy microcontroller to measure the click-to-photon latency and acting as a USB HID mouse and a light sensor against the monitor. After confirming lower latency while playing gaming on Windows, Jacob explored what was going on with KDE Plasma 6.6 Quinn and has worked out some patches to help improve the situation. The patches have yet to be submitted for upstream Quinn, but Jacob noted the gains in windowed games and apps should be substantial. VSync full screen games with direct scan-out should see a benefit of a millisecond or so. Games using VR or full screen games where tearing is allowed will generally not see reduced latency from these changes as long as they stay at or below the refresh rate. These improvements go some of the way to closing the gap between Linux and Windows, as about a 1.1 to 1.2 millisecond gained in the minimums, while the gap between platforms in their best measurements with VR was somewhere around 4 milliseconds. So he's planning to submit these patches for upstream Quinn in the coming weeks, while he also has a few other areas he is exploring for making a more low latency KDE Plasma Wayland gaming experience moving forward. So too bad, though this work will be too late for the imminent Plasma 6.7 release. So really awesome that Jacob is trying to improve the latency. Of course, we also do have things like anti-lag that is being improved recently on AMD. So we're going to see the the latency experience just get lower and lower in a Wayland environment as well, which is really awesome. And then hopefully with Wayland, because that substantially improves the latency versus X Wayland under Wine, the latency is just going to be really freaking good. Then we also do have the Wyvern release that just happened 2 weeks ago. Version 26.6. This is for wireless VR headsets on Linux. So if you don't want to use Steam VR and Steam Link, you can use Wyvern. Really good option, I would say, with like open source VR experience. So what has changed? There's been improved reconnection mechanism now with warnings and errors. That's pretty good to see. Improved image quality when content does not fill the whole field of view. They also added a half FPS mode to reduce load at the expense of frame rate. So I'm really confused about what this necessarily does. Is it like when the headset can't handle the options that you've set on Wyvern, it will cut the FPS in half to reduce the load? Or is it something else? I'm a bit unsure about that. And then fixed Vulkan video encode on NVIDIA GPUs, and then many bug fixes, and then a bunch of new contributors, which is really awesome to see. So we'll continue to see Wyvern just improve and improve when it comes to an open source VR experience with those wireless VR headsets. Then we also do have Flatpak 1.18 that has released, and this includes a pretty awesome new improvement, which is to integrate AMD ROCM or ROCM. And so, if you don't know, ROCM/OpenCL Compute hasn't been supported properly in Flatpak. So if you use Blender Flatpak as an example, which is not maintained by Blender developers, but if you try to use it with an AMD GPU, you can't get ROCM working properly, and usually you need some workarounds or something to, like permission side of things to get it working, or sometimes it just flat out won't work properly. Just weird experience. So with this, it is now supported properly. You can actually see the device being exposed for ROCM to work properly, so that it can you can use ROCM/OpenCL. So we are going to probably see a lot of those applications like Blender, for example, most likely improve the support or introduce this support into the application so that you can use the ROCM compute runtime libraries, etc. on your GPU. Then we also do have Flatten the Pick, Linux patches progress for better C group scheduling while Linux gaming. So if you don't know what the C group scheduling is, it's basically what the Schedule EXT is. So you can pick different schedulers depending on what you want to do on your desktop or server or whatever workload you want to do. But this C group scheduling brings it further, where you can introduce multiple schedulers for different types of workloads running at the same time, basically. So you can have a certain scheduler for gaming, you can have a certain scheduler for this, you can have a certain scheduler for that. It's basically what this is doing. So it's going to, I guess, improve the gaming experience, even though we already have, the gaming distros and stuff that are like Annecy rules, for example, that I've talked about on Kashi, that improves the gaming experience, makes sure the game is like the main priority, and then other distros also do a similar thing, or they use schedulers like LEVD. There's another scheduler that introduces better gaming performance, but it is good that there'll be more of a like standard when it comes to trying to bring a better experience when it comes to whatever workloads you're trying to do, including gaming. And then the last one, we do have the Wayland Protocols 1.49, which does improve the multi-GPU support in Windows BT.2100, which is to do with color management, like HDR stuff. So Sear just published Wayland Protocols 1.49 as the latest version for this primary set of Wayland Protocol definitions. New to Wayland Protocols 1.49 is improving multi-GPU support with the Linux DMA Buff v1 protocol. KDE developer Xavier Huell, the GOAT, worked on the improved multi-GPU support for the DMA Buff protocol back in 2023. For multi-GPU systems up to now, where the client is rendering on a device other than the main device advertised by the compositor, there hasn't been a way for the client to know whether or not a DMA Buff buffer import was successful. With the latest Linux DMA Buff protocol additions, compositors can explicitly advertise support for multiple devices on the system and communicate what formats and modifiers that they are able to sample from successfully. It took a long time to get better multi-GPU support for Wayland squared away, but at least it's here now. And then also with 1.49, also adds Windows BT 2100 image description requests support to the color management v1 protocol, also authored by Xavier Huell, the GOAT. This addition lets Wayland compositors implement special handling for all Windows HDR content. So really awesome to see these two improvements. I've already talked about the other tool, what was it called? Cardwire, I think it was called, something like that, which improves multi-GPUs even further on laptops. So if you have multiple GPUs, you can easily swap between them on the fly without needing to do a restart. Even though there probably is some bugs, there's finally a tool that can do that without needing to restart your device, which is amazing, was developed by the OGC community, which is basically controlled as a community by the Bazite developers. And then also down here was some more fractional scaling support for the V2 protocol of fractional scale. So this new experimental fractional scaling protocol allows clients and compositors to use a different coordinate space for communicating service coordinates and improvement over the V1 effort. So overall, Wayland just getting better and better, which is what we want to see. We really want Wayland to be the best experience that we can have on the Linux desktop, so that, we can just have a really good experience. And that is about it in today's video of this bi-weekly in Linux gaming. There has been some amazing things that have been shown in these past 2 weeks, which is amazing. And we'll see 2 weeks later with more new things that are coming out, and maybe the Steam frame might get an announcement. I really don't know. That's a theory. But if you enjoyed this video, definitely give it a like, subscribe to the channel, and comment down below if I missed anything and what your thoughts about all of these things, whatever it may be. And thank you to my supporters as well. Completely almost forgot about that. Thank you to my supporters. I'll show a text across the screen. Thank you me money every single month. I really do appreciate it. And I'll see you guys in the next video. Peace.